My name is Grace, and welcome to this video on maths proficiencies. This video is going to be broken up into two different parts. Firstly, we're going to be looking at the maths proficiencies, and then we will take a closer look at the mathematical process and how these are both incorporated into the resources. The Australian and Victorian curriculums aim to build proficiency in mathematics through understanding, fluency, reasoning and problem solving. The Australian curriculum, version 9, and Victorian curriculum, version 2, have also added 4 mathematical processes that are involved in working mathematically: mathematical modelling, computational thinking, statistical investigation, and probability experiments and simulations. Similarly, the New South Wales syllabus includes an overarching working mathematically outcome that is present throughout the curriculum that requires students to explore and connect mathematical concepts, choose and apply efficient techniques to solve problems, and communicate their thinking and reasoning coherently and clearly. These are embedded in the syllabus as communicating, understanding and fluency, problem solving, and reasoning. These proficiencies and processes are fundamental to learning mathematics and are applied to all of the lesson materials produced as part of this Mastery in Mathematics project. Let's take a closer look at the maths proficiencies. Let's start by talking about the proficiency of communicating and how this has been integrated into the new resources. Communicating is about students being able to express their ideas about mathematics so that others can understand them through a variety of means, including written, oral, graphical, or symbolic form, through actions, gestures, or signing. Students will be supported in learning a wide range of mathematical vocabulary through the identification and explicit teaching of keywords, and having opportunities to use that vocabulary orally and in writing to describe, represent, explain, and reason about mathematical situations, concepts, methods, and solutions. Let's continue on with the proficiency of understanding. Understanding is the building of a robust knowledge of adaptable and transferable mathematical concepts and structures. Students make connections between related concepts and progressively apply the familiar to develop new ideas. As students learn mathematics in the classroom, they develop an understanding of the relationship between the why and the how of mathematics. Students build understanding when they connect related ideas both within strands but also between strands. In the resources, we've engaged in coherent curriculum planning across units and year levels to support this development of connections across the years. Students also build understanding when they can identify commonalities and differences between aspects of content. In the resources, we have explicit links to prior learning to support the opportunity to develop and explore connections. Teachers can find this prior knowledge information in the first section of the lesson materials, and learning activities explicitly build these connections over time. Students also build understanding when they describe and communicate their thinking mathematically. In the resources, we have included checks for understanding and questions throughout lessons to get students talking about their mathematical thinking. The resources also have multiple opportunities for practicing and applying knowledge and skills, for example, through worked examples. This helps students to interpret mathematical information. Our main tips for teaching the understanding proficiency are: first, to use curriculum codes and units across year levels to identify related content. You can also use the yearly overview and unit overviews for links to curriculum content. Second, to use unit overviews and lesson detail to identify prior knowledge. Reteach if necessary before teaching new content using the provided reteach packs. Finally, check in with what students understand about mathematical concepts. Ask questions, inquire about their learning, and use the check for understanding and learning activities in the resources to explore what your students know and are able to do. Next, let's talk about fluency. Fluency describes the development of students' skills of choosing and applying appropriate procedures, carrying out procedures flexibly, accurately, efficiently, and appropriately, and recalling factual knowledge and concepts readily. Students are fluent when they make reasonable estimates and calculate answers efficiently. To support this learning, the resources include daily review, a 10 to 15 minute block of time in which students practice previously learnt skills. With the daily review resources, students practice key facts and skills, and have repeated opportunities to road test strategies, including problem solving. Fluency also involves recognising robust ways of answering questions. The resources are designed based on explicit teaching of content, approaches, and strategies. This ensures students learn strategies and approaches that are most useful for answering mathematical questions. Students are also fluent when they can recall definitions and regularly use maths facts. The resources have opportunities to practice application of learnt content. Our main tips for teaching the fluency proficiency include: first, to use daily review for fluency of key maths facts and retrieval and application of learning. This will develop and maintain efficient recall. Second, to use lesson worked examples and lesson activity practice questions to deepen understanding. Next, let's discuss the problem-solving proficiency. Problem solving is the ability of students to make choices, interpret, formulate, model and investigate problem situations, select and use technological functions, and communicate solutions effectively. Students pose and solve problems when they apply their existing strategies to seek solutions. The resources are based on a sequenced curriculum, which is designed to build on existing knowledge. This helps to develop problem-solving skills over time. Problem-solving skills also involve verifying that your answers are reasonable. The resources have been designed with units that provide a deep understanding of numbers and number systems and frequent opportunities to utilise their number sense. Guided practice ensures that students understand how to assess their answers. Our main tips for teaching the problem-solving proficiency include: first, break teaching down into steps. Use the lesson detail and slides to ensure students have a solid understanding of concepts, skills, and content, so that they can apply these flexibly to problem solving. Don't be tempted to rush through. Second, use the rich task lessons to apply learning to investigations and more complex problems. Rich tasks are also embedded in other lessons. And third, use formative assessment and checks for understanding to ensure that students' answers are reasonable. Give frequent, real-time corrective feedback as part of this. Lastly, let's talk about the reasoning proficiency. Reasoning refers to students developing an increasingly sophisticated capacity for logical, statistical, and probabilistic thinking and actions. This includes hypothesizing, analysing, proving, evaluating, explaining, inferring, justifying, refuting, and generalising. Students are reasoning mathematically when they explain their thinking. We have therefore designed opportunities for checks for understanding, which are embedded in resources. Mathematical reasoning also involves adapting the known to the unknown. With the sequential curriculum resources, teachers can build on student prior knowledge, problem solving, and application of knowledge and skills. Students are also reasoning mathematically when they prove that something is true or false. The resources give teachers advice on possible student misconceptions and how to address them with the use of examples and non-examples. Finally, the resources guide teachers to explicitly teach different methods of solving problems, and then apply these methods to different situations to determine which is the most efficient option. This helps students to compare and contrast related ideas and explain their choices, which is important for mathematical reasoning. Our main tips for teaching the reasoning proficiency include: first, use checks for understanding and questioning for students to explain their thinking and to identify misconceptions or common mistakes. Second, use activation of prior knowledge at the beginning of the lesson to explicitly connect prior knowledge to new content. And third, provide examples and non-examples, as well as examples that have not been worked through correctly to encourage critical thinking. Now, let's move into the second part of this video, mathematical processes. First, mathematical modelling. Mathematical modelling is used to gain insight into and make predictions about real-world phenomena by setting up and using mathematical models that represent or approximate the situation as closely as possible. The Australian curriculum provides this structure for the modelling process: understand, plan, do, consider, and communicate. Students will make assumptions, recognise, connect, and apply mathematical structures for their mathematical models. The modelling process utilises mathematics to formulate, analyse, solve, interpret, generalise, and communicate their results in response to a real-world situation. Students will have opportunities to mathematically model scenarios in short form during lessons and in longer form during rich task lessons. In addition, we will be providing sample assessments, some of which will demonstrate how a teacher can set up additional modelling assessments. Next, let's talk about computational thinking. The term computation is used in mathematics to refer to operations, transformations, procedures and processes that are applied to mathematical objects to produce an output or result. Computational thinking approaches involve experimental and logical analysis, empirical reasoning, and computer-based simulations. Computational thinking is made up of decomposition, abstraction, pattern recognition, use of models and simulations, algorithms, and generalisation. Students will have opportunities to think computationally throughout the lessons as they learn to apply new concepts, use formal and informal algorithms and procedures, make and test conjectures, and generalise concepts informally and algebraically. Next, let's look at statistical investigation. Statistical investigation deals with uncertainty and variability in categorical, nominal or ordinal, or numerical, discrete or continuous data arising from observation, surveys, or experiments, and can be initiated by a specific question, a situation, or an issue. The Australian curriculum provides this structure for the statistical investigation process: understand, plan, do, consider, and communicate. Students will have opportunities to apply statistical knowledge and skills to statistical investigations built into the statistics unit. Finally, let's talk about probability experiments and simulations. Probability experiments and simulations continue to deal with uncertainty and variability, where data is collected through experimentation and simulation using digital and analogue tools, often to generate large sets of data for consideration. Experimenting in mathematics requires students to plan what to do and evaluate what they find out using mathematical reasoning. Students will have opportunities to run probability experiments and simulations in the probability units. The curriculum and resources are designed to develop students' skills in the mathematics proficiencies and processes, and so are an integral part of our teaching resources. Thank you for watching, and we hope this video has been helpful.